Hello, this video is on section 7.3, which is titled Logarithmic Functions and Inverses. The learning targets for this one are to write and evaluate logarithmic expressions and to graph logarithmic functions. And unfortunately, I don't have my graphing calculator with me, so in class I will show you guys how to graph and where the log buttons on the calculator are. But first, when we get started, finding the inverse of an exponential function that is the parent y equals b to the x, it's exactly how you're used to it, where you switch the x and the y, so your y is now in the exponent, and it's equal to x. But the way you actually solve for the y and get it by itself is not really taking the y root, I guess that sounds kind of funny, of both sides to get it by itself. What we're going to introduce is something that's called a logarithm. So if we have a function that is b raised to the y equal to x, the way you get it by itself using a logarithm comes from this certain expression. Logarithm for short is log. And the base of your logarithm is going to be the number that goes underneath. It's kind of an underscore, the opposite of an exponent, it goes underneath. And it's going to be the exact same b that's over here. Notice that b is our base. So it's the base of our exponent, and log b is the base b of this logarithm. And we're going to take a logarithm of our x, and this is going to be equal to y. This formula and conversion rate is the most important thing to know when converting logarithms to exponents. A phrase that you're going to hear me say often is that logarithms equal exponents. Exponents. TS, not ST. So that when you take a log of something with a base of b, it's going to equal your exponent in exponential form. The y is the exponent here, and that's what's going to be equal to the y. That's one way that I always tell myself the exponent is going to be by itself in my logarithm when I'm converting it to find the inverse. So let's take a look at a few examples. Let's say we have 100 is equal to 10 squared. This is of course true on both sides, but if we're trying to find this rewritten as in the form of a logarithm, we have our x is equal to b raised to the y in this form. And remember that the form for our logarithm conversion is log base b of x is equal to y. So our exponent in this example is 2. Our x is 100, and our base is 2. So log base 2 of 100 is going to equal 2. Same thing with 81 equals 3 to the 4th. Converting it to log base b of x equals y. My base is 3, and I'm taking it of 81 to equal my exponent. This is converting from exponential form to logarithm form. Okay, and then evaluating logarithms, there is a way I could show you to do it by hand, which I'm going to do very quickly, and I don't think is that important for you to pick up on since you're going to be using calculators on the ACT and wherever you go. But if you have your log base 8 of 32 is equal to some number x, you're going to convert that to exponential form, which means that your base raised to the x, which is your exponent, is going to equal 32. Now finding common bases between your 8 and 32 are of course going to be 2, and 2 raised to some number that equals 32 is going to be 5. And 2 raised to some number to get 8 is going to be 3, and this is going to equal x. So since we have common bases, we can say that 3x is equal to 5, and solving for x we get divide by 3 on both sides, 5 over 3. This is how you solve it by hand. You are probably never going to be doing this in my class. You may in some other classes like ICA, if you get to college level math, you will probably have to know this formula for bases. But one thing that I do want you to start getting is something that's called the change of base formula. And I may be completely working ahead of myself, but I feel like this is the most important thing from the chapter. So in any logarithm that you type in the calculator, you're going to hit log and a parentheses is going to open up. No matter what you do, your base will always be 10. This is known as the common log or common base of a logarithm. Now, a way that you can evaluate these in the calculator to get around having a base of 10, like in the last problem we had a base of 8, I think it was, where it was log 8 of 32. A way you can get around doing it is by using what's called the change of base formula. And the change of base formula uses a division of logarithms that each have a common base, and most likely is going to be 10 that you use in your calculator, where the numerator of your fraction is 32 and the denominator is your base. By typing this into the calculator, you should still get your same answer, that is 5/3. Or if you get it as a decimal, it'll be 1.66 repeating, and then rounding to the 7 for the last number. But so your change of base formula takes your second number as the numerator on top, and then your base as the bottom number that you take the logarithm of. We'll do a few examples with the calculator in class, but just one more very quickly before the video is over. Let's say if we're looking at log base 5 of 125 and we want to evaluate this using the calculator. Now, I don't know entirely what this is off the top of my head since I don't have a calculator handy, but the change of base formula application will be taking log of 125 and dividing it by log of 5, and typing that into the calculator will give us our answer, whatever that number may be. Okay, thank you.